Hello everyone and welcome back to Hacktivity Explained, the series where I go over some bugs found by other bug bounty hunters in the hopes that you might learn a little bit from them. And in this video I'm going to be covering two SQL injection vulnerabilities, one which was found on Uber and the other which was found on Grab. So SQL injections aren't vulnerabilities that I look for very often, and honestly I don't think a lot of people look for them, but they're definitely still around, particularly in technology that's outdated and in kind of inconsistent implementations or third-party implementations actually as well. So I want to look into these two vulnerabilities and see how people are actually still finding SQL injection vulnerabilities, considering that they're quite high impact as well. So without further ado, I'm going to start by explaining what SQL injection is first, and then I'll move on to the two reports. So first of all, SQL is basically how the server talks with its backend database. A database is where all the data about like users and stuff like that is stored for a website. And in order to communicate with this database, the server uses SQL. So what will happen is the server will send a SQL query, as it's called, and then after that, the server normally returns data or some kind of action happens, like a new table is created or something like that. So this is like a common example of how a SQL query might look like. This is just a select from statement. So what this basically will do, and it's different in other SQL languages, but we'll just take this for as an example. It'll take this table, so this like placeholder name is X here, and it'll try and find all the values where there's a condition called Y is met. So this could be used to, for example, take like a user based on his ID. So the website will allocate each user an ID in the database and then basically fetch it after. So that's basically how it's commonly used. And basically SQL injection is when user data is user input is placed into a SQL query without being sanitized. So this is a Python example of how a SQL injection might work with the example we saw before, right? So in Python, you can add this F symbol here to your strings, and that will allow you to insert variables into them. So here we have the same statement. We say where ID is equal to ID. So ID is some kind of variable, and let's say it's user controlled. So when you have like the URL and you have like the query parameters, let's say this is where the ID comes from. So the reason you don't want to do this is because when you insert user input into an SQL query this way, the person can actually extend the query and actually place their own query values in there. So as an example, if we had this here, we could, for example, put like 1 down here and then finish the query here by placing a semicolon down and then start writing a new one. And if the server returns the response to this query, we could fetch like the whole database. And the server shouldn't allow us to do that because there could be other users' data stored there, which is going to be sensitive. We could, for example, append like or 1 is equal to 1 here, and this will return all the values where the ID is 1 or 1 is equal to 1. So 1 is equal to 1 is just true, so it'll basically return all the values to us. And obviously that's a problem for a company which wants to safeguard its users and protect like GDPR laws. So that's why you shouldn't place user controlled input directly into a query string like this. And you should use something called a parameterized query, which is something supported by every SQL engine at this point. And it's basically a way of telling the engine what's user input and what isn't. Like what part should be interpreted as the query and what part should just be interpreted as like a value, like an ID. So that's essentially what SQL injection is. It's where user input is placed into a query string without being sanitized and without being parameterized. So now that you understand that, let's look at the two reports of bug bounty hunters who actually found this vulnerability in public programs. So we'll start with the first report, which was found on Uber. And this was actually found on the Chinese version of Uber, because the hunter was just traveling there and he started using Uber in China. So there's this you can subscribe to this kind of newsletter, and a lot of companies do this where you can like place your email down and you can get like events like notifications and stuff from the company. And it's the same in Uber, so you place your email, etc. And then because of GDPR, actually, they have to give you an option to unsubscribe for it later. So there was this link here, this unsubscribe link. Oops, let's make that nicer a little bit. This unsubscribe link here, which basically took in your email and your user ID as a parameter. And it did so in this weird base64 encoded string. And if you've ever looked at JWTs or JSON Web Tokens, you'll kind of see this telltale sign, this EYJ1. And what that basically is a base64 encoded left curly bracket. Yeah, that's what it is. And that will often mean that the value inside this base64 encoded data is actually JSON. So when the hunter decoded this, he saw inside this thing right here. So this kind of base64 encoded JSON data, which contained user ID and some kind of other piece of data here. So when you see values like this, let's get rid of that. Let me actually move my head out of the way as well. Go. So when you see values like this, it's often worth testing some kind of polyglot payload. So I would test like a server-side template injection payload, maybe it's kind of XSS payload, or in this case, a SQL injection payload. So the hunter realized that this parameter here, the user ID parameter, is actually vulnerable to SQL injection. And it could be converted into a string like this, and then this kind of payload could be injected into it. And the reason the hunter figured out it was an SQL injection was because of something called a sleep command, right? So you can tell the database basically to kind of like stop working for 12 seconds, just wait 12 seconds. And when you send your request with the sleep command in it, and it takes exactly 12 seconds to come back, you know there's an SQL injection because the database has slept for 12 seconds and the server had to wait for the database to respond. So that's how the hunter confirmed that there was an SQL injection here. Then, usually to show impact, you can use a tool called SQL map, or in this case, the payload that the hunter actually built themselves. You can use SQL map to leak stuff like the database name here, and the user of the database. And this basically shows that you can actually extract data from the database that you shouldn't be able to extract. And with this, you can basically extract the entire database. So you could extract user emails, you can extract like names and anything that Uber stores on these databases, which could be sensitive or could not be sensitive depending on what it is. Back in the day, companies used to just use one database for everything. Now it's a little bit more secure with most databases being split and microservices, etc., etc. Talked about this a little bit in my previous episode on microservices, but SQL injections will still mostly have high impact either way. So the hunter got $4,000 for this vulnerability, which isn't actually a lot for an Uber SQL injection. Uber is a huge company and they actually pay out quite a lot. But this was in a third-party application, so it wasn't really entirely Uber's fault. They were using some kind of other email provider. But yeah, they basically fixed the vulnerability, and the hunter got 4,000 for it, which is pretty good. So what to look out for? What can we learn for this report? I think the big thing is that inconsistencies between websites often point to some kind of outdated software. So when you have like different versions, like a Chinese version of Uber or like some kind of different implementation, you should actually often test those things because they often rely on technology which isn't used anymore, particularly the Chinese versions. And the reason for this is that China has restrictions for what websites can do. They often have weird, different, complicated rules. the Chinese government like maintains like some kind of a little bit of censorship online. So companies often have to adapt their websites to this, and it's often it's hard to maintain a lot of different versions of websites. They need a lot of developers for that, and so sometimes the technology gets outdated and stuff like SQL injection just get left in, even though they're really shunned nowadays because they're a very well known vulnerability. But that's kind of how these things happen. And then just kind of testing polyglot payloads on something like this, just spotting that this is base 64, kind of just past knowledge of this. So yeah, that's kind of the main thing about this vulnerability. And I guess the real big thing about this was that probably no one else was testing the Chinese version realistically. So that's kind of what gave this hunter the advantage and allowed them to find the SQL injection. So now we'll move on to the next report, which is on Grab. But before we do, I just want to mention that I actually have bug bounty labs now, and they're specifically tailored to server-side attacks. So like this SQL attack, it's a server-side attack. And there are 12 hands-on labs that you can go try it yourself. They're all online, so you don't have to download anything. And there's also written solutions. If you feel like you're a bit stuck in your bug bounty journey, you've maybe found like one bounty or you haven't found any, but you can actually like you actually know what the vulnerabilities are, you just can't apply them to real websites, then I highly recommend my course. I think it would help me if I had it back in the day. So go check it out, it's in the link in the description. And we'll now move on to the next report. So our next report is in Grab, which I think is like a food delivery app or something like that. I'm not really sure. But either way, Grab uses WordPress like a lot of websites do. And they used a plugin called Formidable Pro, which, as far as I know, allows you to create forms like Google Forms on your website when you're using a WordPress site. And quite a lot with WordPress plugins, actually, there's often quite a lot of vulnerabilities in them. So websites will use these third-party plugins, and then often there's like some kind of bug in them. They're not like 100% maintained at all. Like usually the plugins aren't like I think they're free, so the developers don't really actively maintain them that much. And some bug bounty programs will actually not reward this. They don't reward WordPress plugins because they're considered like third-party software. They don't consider it like something that they should fix. But in this case, Grab actually did reward this vulnerability, which is interesting. So sometimes you will get rewarded for this, sometimes you won't. WordPress actually has their own bug bounty program for plugins that are quite used. I think it's like over 100,000 downloads, so you could try and report it there as well. But either way, this was a third-party WordPress plugin, so keep that in mind. And basically, this plugin was intended for admins. So admins were supposed to be able to create forms and stuff like that, and then basically and distribute them to their users. But some endpoints were actually unauthenticated. This is common across a lot of WordPress plugins where it's like broken authentication and stuff like that. And that basically allowed unauthenticated users to access some of the endpoints. And one of the endpoints was a preview for a form. So you could preview a form before you like saved it and stuff like that. And in this case, you could also use parameters. So you could add a few of these like here. And this endpoint was unauthenticated. And in one of the important parameters was this after HTML one, which allowed you to include some HTML after the form. So now I have to explain WordPress shortcodes. So WordPress shortcodes are kind of like small, like a ways to write code without actually writing them. So it's these kind of shortcuts. I'll show you the website actually. It's quite hard to describe now, but say you wanted to like embed a YouTube video. So the way to do that normally is you have to like import this like JavaScript and you have to like run this like JavaScript stuff in your browser and then obviously embed the video. But in WordPress, you could just do that very easily by just doing these square brackets and saying YouTube and then the YouTube link, right? So it was just a way to speed up the development and basically reduce the amount of JavaScript, stuff like that. And then obviously plugins themselves can also implement their own shortcodes, so they can do different things, like basically put on like HTML, and in this case you could order your data. So you could put like a list down and you could order it by some kind of value, which you can see here. So this form plugin also accepted shortcodes, and you can see them here, right? You can see the display data, display form data with an ID, and then of course some kind of way to order. And one of the parameters here, order, was vulnerable to a SQL injection. So order by is actually a SQL keyword, and it's used to basically change the way that the database returns data. And in this case, it accepted the word ask and desk. So ask is ascending and desk is descending. So it'll either give you an ascending or descending order. You can basically change it. And then order by is basically order it by some kind of value. So obviously the order here parameter was injected directly into a SQL query by the plugin, which is unsafe. These values should probably be sanitized before they're injected. And because of that, an unauthenticated user could actually send a SQL injection, which the hunter found by basically sending a value other than the two previous values mentioned, and then you got an SQL error. If you get an SQL error message, it actually is very often going to be an SQL injection, because these kind of error messages should not be shown to users. It's bad practice through that. It kind of hints at some kind of vulnerability. So websites should hide these error messages from you. In this case, it was shown to the hunter, who then basically proceeded to start building an SQL payload. And the easiest way to test it is just by doing a sleep command and then seeing if it will stop freeze the database. And then you can use a tool called SQL map, which here you go. So you can use it, for God's sakes, use a tool called SQL map. And I mentioned this tool before, but it's just used to exfiltrate data from a database. It just saves you having to do like all of this stuff here. You can see it's just like annoying. You have to type in a lot of stuff, and it's a very manual work, especially when it's a blind injection and the server will not return the response to us. So using this tool just saves a lot of time, and in this case, you can just type in SQL map and then type in like the request you want to send, and then it will automate most of the work for you. And in this case, yeah, basically to prove the vulnerability, the hunter extracted like the admin's users and their passwords. So, oh yeah, this hunter I think went a little bit too far in this case. I don't think you need to extract as much data to prove the vulnerability, but the hunter extracted all of the tables and then all of the admin users and their passwords. So that was basically how the hunter proved the vulnerability was there. And yeah, so what can we learn from this? Well, I think the kind of key thing here was that the hunter used a lot of recon here. So I made a previous video about fuzzing and trying to like find directories and stuff like that, trying to find unauthenticated endpoints. And this is kind of the biggest piece of work here that I think the hunter did here, was looking for this was looking for this directory and then basically finding its parameters. So once I imagine the hunter established that this plugin was being used, probably went out and looked at the source code for the plugin and stuff like that. All the plugins for WordPress, I think most of them, are open source, so you can just have a look at what's inside of them, and then you can basically start looking for vulnerabilities. And in this case, he or she found the SQL injection vulnerability. So the company kind of gave an explanation for why they rewarded this third-party plugin, and they kind of just said that they rewarded it because of impact. Apparently, they probably stored data on the WordPress site and they wanted to protect their users. So he got a pretty generous 4,500, I think, for third-party tools. And yeah, I think that was the main thing from this report, and just using SQL map to kind of speed up the journey there. using recon, etc. Yeah, so those are just the two kind of reports I want to talk about which had a SQL injection vulnerability, and they kind of show where you can kind of still find SQL injection in modern websites, mostly in older, outdated technology, some kind of third-party software where there might not be cybersecurity researchers actually testing on it. So basically, like older features or different versions or older implementations and stuff like that. And yeah, as I mentioned before, I have my bug bounty labs in the description. Do check them out, please. It's 12 hands-on labs, so they might help you find vulnerabilities like this. Maybe someday I'll talk about your report. Maybe you'll be on my videos after you complete the bug bounty course and you find a couple of server-side vulnerabilities. Who knows? Well, anyways, I'd like to thank you for watching and happy hunting.